Okay, well, welcome everybody. My name is Ron Schreiner. I'm an organizer of quantum computing, Chicago, Illinois, and beyond. And don't know if Barry's still here. Barry's another organizer. Just want to mention to everybody, if there's quantum related stuff that you're interested in finding out about, let us know. Can't guarantee we'll find a speaker or be able to speak on it, but we can give it a shot. If anybody in the crowd has a presentation they would like to give, contact me on meetup.com. You can just message me there, and uh, we'll see what we can put together. We generally we've been working towards getting one session a month, but that's not set in stone. If we get enough traffic, we can do more than one session a month. But speaking of events, our next event is August 14 at 3 p.m. Central Daylight Time with Michael uh, Stetchley, and he'll be talking about quantum resource estimation. Sounds like a QAOA type of thing, maybe. Who knows? So be on the lookout for that. Um, Just want to mention, if you guys, I'll ask Bill in a second, but if you're not, um, yeah, if you're not speaking, keep your mic muted, and only turn it on when you have something to say, so we keep the background noise down. So with that, I'm going to go ahead and introduce Bill. Actually, I've been acquainted with Bill for some time now. He's the CEO and president of Slater Technologies. Did I pronounce that right, Bill?
Yes.
Incorporated, based in Chicago, Illinois. So we're kind of neighbors. He is an experienced, certified, seasoned, and published IT professional with more than 4 decades of experience. Boy, you really hit that on the head when you said you and I are alike. Um, pre- Presently, he works as the CTO and CISO of the marketing organization, a San Diego, California firm I trust. And he has several projects, including blockchain, AI, and quantum computing. So, with that, Bill, I'll turn it over to you. And looks like you can tell us about the SecDef stuff that you've been also working with.
Sure. Um, first of all, I think one of the greatest lies in the world is when an organization or a presenter says, "Don't worry about taking notes or screenshots. You will be provided the slides," and then you never see the slides. So I'm going to put this in the chat, and you guys can go look at this. Um, This is up on my personal website. This is the quickest way to get to this presentation, so you can just download the PDF and have fun with it. Um, a lot of research and experience went into this, so you get to be the beneficiary of this. And I will tell you at the end of it, maybe some of you know this term, Easter eggs. If you go look at the references, there's some Easter eggs in the references where by some of the references you will see a icon that shows the bright shining sun. Excuse me, the bright shining sun. So if you go look at those particular references, those were the best references I used to put this presentation together. So there's a lot of value there, and I'm a voracious reader. You can see my background. That's not a that's not a manufactured background or a simulated background. That's about 1% of my library. I live in a library of about 18,000 books. Um, my partner, I just wanted to bring him up before we start the presentation. It's the other beautiful bald-headed gentleman over to the top of the screen, Mr. Joe Reddix. And Joe and I, we're both U.S. military veterans. He served in the Navy, and I served in the U.S. Air Force. We both got our IT careers started there, and we're partners, we're buddies, and I'm grateful for his encouragement and just being an all around great colleague. So very inspirational man, and I'm also proud to say in a profession where there seems to be a lot of discrimination against people over 40. Joe and I have over 100 years of experience together. And Joe, you want to say anything before we get started? Joe, you got to come off mute. I guess Joe was maybe being shy and just didn't want to speak. But anyway, um, uh, we're we were having some technical difficulties, so he's helping with the slides tonight. Okay, so this is our title slide here, building a quantum foundry, and I got some expert advice from Ron. Apparently, there's already a website called quantumfoundry.com, so we didn't want to step on their toes. So we're giving our insights on building a quantum foundry tonight, so that people kind of get our perspective on this. I think it's a valuable perspective. Um, Next slide, Joe.
By the way, Bill, I can hear you okay. Can you hear me?
Yes, Joe.
Okay, we're good.
Before we get started, you want to make any comments?
No, I think that everything that you're presenting is right on, and you can just say we're going to do the ditto here in the DC area. So when we create this foundry, there are two locations I see, definitely Chicago area and here in the DMV. Okay,
Beautiful.
gotcha.
Okay, so I grew up in Memphis, and one of our I have a minor. I have a major in computer systems technology and a minor in manufacturing technology. And in my senior year, one of our um, courses I had to take was about going on all these manufacturing um, concerns in Memphis, and one of those was a foundry. And so, and in a real foundry, there's a lot of molten molten steel, and steel is comprised of recycled steel and iron and carbon, and they heat it up very hot, and then they pour it into casts, which are kind of ugly, and it's not particularly safe or healthy. These casts are have sand in them, and the sand is formulated, made malleable by formaldehyde, and so they pour this molten steel in there, and then they let it cool, and they're making parts. So this is the kind of automated industrial revolution of manufacturing in steel, and this goes back to probably World War I and World War II. You know, it's been around for a while, but now we're in the quantum era, and we don't get the luxury of doing just a one-off every time we want to do something. So we we have to apply industrial age um, manufacturing principles into the world of quantum in order to make things that are going to be economically viable. So this is our outline here. Introduction, announcements. What is a quantum foundry? We're going to talk about that. The benefits and advantages of this. what gets made in the Quantum Foundry, how do you establish a Quantum Foundry, examples, cautionary tale, the conclusion, questions, and some references, and there's an about me slide at the end. Joe, next slide, please. Okay, so we're now living in the quantum age, and we're right on the verge of having not only one but several different types of quantum computers. We're in a quantum arms race with China, and so there's all these this quantum hardware, algorithms, and software that are now evolving rapidly. Big players, industry leaders like IEEE, Google, Microsoft, IBM, Intel, NVIDIA, and DWave are all working diligently to help bring in this era. And so the standards are rapidly evolving and maturing. And so we're at the point where the introduction of building a quantum foundry will further refine and advance the use of quantum technologies using repeatable processes and best practices. Next slide, please. I want to make some quick announcements. First of all, you can each receive a copy of the presentation. This is the other URL. You can go to billslater.com/quantum/quantumfoundry.pdf. It's out there. The other a couple of announcements. I guess this is a plug for Chicago Quantum Meetup. The next meeting will be August 14th, about 3 in the afternoon, I believe. And then our other announcements here, we've got DARPA. Joe and I are working together. In fact, a week from now, I'm going down to Urbana-Champaign to a DARPA conference. And a week from now, Joe will be in a DARPA conference up on Capitol Hill in DC. So we're both working our leads inside DARPA, which is the Defense Advanced Research Project Agency. And just in case you guys were not aware of that, because you hadn't been in the field as long as Joe and I, these are the people that originally funded the ARPANET, which came online in September of 1969. And in 1983, this became the internet. So DARPA doesn't play around. The projects that they fund actually have considerable impact once they come to fruition. A couple other announcements. We have a quantum hackathon, and this is going to be one of the world's most unusual quantum hackathons, because most hackathons, you beat your brains against a wall for about 3 or 4 days, 2 or 3 days, and you feel terrible when they make the announcements of who won, because you're very sleep deprived. We're sponsoring a 30-day quantum hackathon starting on October 3rd, which is the day that I turn age 70, God willing. So it'll be very interesting quantum hackathon. First prize, we plan to have a $5,000 cash award. Second prize will be $3,000 cash award, and third prize will be $1,000 cash award. So watch this space. It's going to be very interesting. And because the quantum world is small, we will allow international participation. And then finally, special bonus, there's going to be 2 slides in this deck that contain extremely valuable information, and these will be symbolized by a gold star with a red $sign in it. Next slide, Joe. So Quantum Foundry here, we pulled up definitions from Bing, and also a couple of different universities, but basically it's a specialized facility dedicated to design, prototyping, and fabrication of quantum chips tailored to specific requirements, and we're kind we're kind of expanding that definition to also include software. But we've got definitions from Quantum Foundry in Copenhagen, and also at the University of California at Santa Barbara. And I'm not going to read this to you. I'm just going to let you know that this is out there. Next slide, Joe. We categorize the benefits and advantages of a quantum foundry in this nice diagram here. There's scientific and technological. There are strategic and economic advantages. There's talent development and workforce enablement. And I've got a slide down in the deck that talks about how many people and the types of people that are in the quantum. I think what might amaze you is there's worldwide, there's not as many people as you would think. And the message here is that if you are interested enough in quantum to come out to these meetups and you want to get involved, please roll up your sleeves and contact people like myself and Joe, because you can get on board with early with the Quantum Foundry and the things that we're doing. Right now, we don't have paid positions, but if things break out the way that we expect that they will, there will be paid opportunities, and people like myself and Joe and others will be mentors and stuff like this. So we'd like to grow this field rapidly. Other advantages are broader societal and scientific impact, infrastructure and ecosystem building, and the advancement of best practices and security for quantum computing. Next slide, please. So this is kind of an outline of the benefits and advantages on scientific and technical advantages, accelerated innovation, standardization, and repeatability. And this is where you get a key economic advantage, because once you can turn this into a quantum industrial revolution, you don't have to reinvent the wheel every time. Cross-disciplinary collaboration and scalable fabrication. Next slide, please. Strategic and economic advantages, national and technological sovereignty. We just happen to be living in an era, and this is just an editorial comment, I try to keep politics out of things, where we have a national leader who doesn't like to be second place in anything. So the feeling is in DC that come hell or high water, the prevailing philosophy right now is they want to make things happen, because they don't want to be second place to Europe or China. So, you know, I think overall that's good news for America. Market leadership and also IP creation, and this is intellectual property creation and commercialization. Next slide. Talent development and workforce enablement. This is a huge one, and I'll just challenge people. How many of you knew that Governor Pritzker and some of his colleagues intend to see the thing called the IQMP, which is on the far south side of Chicago in the old National Steel area? It's called the Illinois Quantum Microelectronic Park. So they intend to use the muscle and the know-how of Illinois, particularly with components of being able to supercool computers with things like helium and stuff. They intend to have that park that they're talking about, the IQMP. You can go do an internet search on it, to be the #1 quantum center of the United States. I'm sure that they have the industrial power and know how to do it. I don't know if they have the brain power. And so, and also, if you know Illinois, there might be some people that are hesitant to commute to that area. But anyway, I have hope for Illinois that we can be number one in this. We'll see. Um, and then the next one, hands-on training and upskilling, and which is why you're here, and the pipeline for the next gen experts in this field. Next slide, Joe. Broader societal and scientific impact, enablement of breakthrough applications. And this is going to take a lot of creativity, but I'm sure we got it here in Illinois. And also collaboration hub is what you would find in a good Quantum Foundry. Next slide. Infrastructure and ecosystem building, a reusable design and process, intellectual property, and supply chain development. Because once the floodgates open, quantum is going to really become a part, I think, of most viable economic solutions. Next slide. So what are the benefits and advantages here on advancement of best practices in security and quantum computing, identification of possible security issues, team communication to stakeholders on the security issues, and also management of security issues. Next slide, Joe. So the approach that we took for the Quantum Foundry initial thing that we'd like to build is working on quantum sensors, and quantum sensors utilize properties of quantum mechanics. This is extremely important. Utilize properties of quantum mechanics such as entanglement, particle, quantum interference, and quantum state squeezing, which have optimized precisions and beat the current limits of current conventional sensor technology. Next slide. I love this quote from this author practitioner, a guy named Davidovich, but he says quantum sensors allow the estimation of perimeters with precision higher than obtained with classical strategies. Devices on quantum physics, devices based on quantum physics have allowed the precise estimation of the gravitational field and detailed imaging of the brain, the detection of gravitational wave sources more than 400 million light years away, and an ever-increasing precision in the measurement of time. Quantum, and this is the theme of the entire presentation. Quantum metrology is which is the conceptual framework that encompasses all these devices, is reviewed here, emphasizing recent results regarding noisy systems. Next slide, please. Okay, this is one of the most important slides in the entire deck. And when you get this in your hands, when you get the PDF in hands, please remember that slide 16, I think that's 16. Slide 16 is one of the most important slides because I outlined it in red dashes. We are here. So we're getting down into quantum metrology, and a lot of people sign up for conferences, web conferences like this, and they think, oh, we're going to learn about quantum computing. No, in this conference, you're learning about quantum metrology and Quantum Foundry. Okay, so this is different than quantum computing. Can you use this with quantum computing? Yes, you absolutely can. And you can also use this with artificial intelligence. But please don't confuse quantum metrology with pure quantum computing. Next slide, please. Okay, so how do quantum sensors work? You prepare the quantum system, you expose to the physical quantity, you measure the quantum state, and then you do data interpretation. And number 4 there, data interpretation, if you collect enough data that you can do analysis using AI, this is where AI comes into play. And by the way, this presentation is so well researched that when you see a reference there, boom, comma S, comma 2004, that's directly in the references at the end of the presentation. So you can go directly out to that paper, and I believe that goes straight out to a web link. Next slide, please. So what gets made in the Quantum Foundry? Well, here's a short list of quantum type sensors that are in use today. Quantum magnetometers, atomic clocks, quantum gravitometers, quantum accelerometers, quantum thermometers, and quantum LDAR, which is light detection and ranging. Next slide, please. Here's a similar list that came out of the National Council for Science and Technology from 2022. And I think the big one on here, the two that are different here are the devices utilizing quantum optical effects and also the atomic electrical field sensors, going from gigahertz to terahertz radiation detection. Next slide, please. And here's a nice graphic that I was lucky enough to find on the web. This is from the Government Accountability Office, surprisingly, and it's only 2025. This shows current available sensor capabilities, and then how you would upgrade that in a quantum world in the lower half there. Next slide. And this is an example of a device called a gravimeter, and this is an example of a quantum sensor. This is from 2024. Next slide, please. Okay, I love the slides that came out of MITRE, and the author was a young lady named, her last name is Backus, but basically she shows the devices that exploit quantum phenomena to measure physical quantities, and these are the categories: clocks, inertial sensors, gravimeters, magnetometers, electronic field sensors, and photonic. And if anybody remembers when you were in maybe kindergarten or first grade, and they introduced you to Play-Doh, which was always pretty. I don't know how many of y'all know about Play-Doh, but it's made out of flour and colors, and it always smelled good. Whenever you smelled play, you never wanted to eat it, but it smelled pretty good. Think of the idea of being in a quantum foundry is playing with Play-Doh and making stuff with your hands. They are going to wind up being useful like tens of thousands of times over. So, this is an example of, in other words, it's not fixed. People that come into the Quantum Foundry under the guidance of a strong leader can solve business problems, but when you boil it all down, you can think of making useful things with Play-Doh. Next slide, please. So this is again a great slide from Ms. Backus. And basically, this is the maturity range of quantum sensors. And you know, it's everything is not cast in stone here. This tells you all the types of sensors, and it goes from the spectrum from laboratory demonstration all the way to commercial, off the shelf in terms of the spectrum of maturity. Next slide, please. Okay, this is facilitating the development and utilization of quantum sensors. And this is recommendations to facilitate the development and utilization of quantum sensors. And again, there's a lot of research that went into this, but I wanted to give the reader and the audience the opportunity to understand that this, you know, that this is a we're living in a world where people have put some standards together to facilitate the development and utilization of this stuff. This is not, you know, we're not making this up as we go along. People have put some formal ideas around this. Next slide, please, Joe. Okay, so this is the future and development challenges. There's two categories. Key challenge one is miniaturization and ruggedization. And the second challenge is connecting end users and researchers, end users with researchers and developers to accelerate the R&D pipeline. And I'll give you an example. 2 days ago, I was in a conference with somebody who basically, she was kind of like blue skying or black skying, whatever you want to call it, because she was literally talking about putting not only one satellite in orbit to use quantum principles, but also to build a constellation. And I have no idea where this young lady would get this kind of money, but she was talking about it. And so one of the first things you look at when you start talking about putting quantum devices in orbit and in low orbit, or we say LEO, which is a low Earth orbit, or I think there's a middle Earth orbit range, and then there is a geostationary orbit. So one thing that you look at when you start talking about putting components and quantum sensors and space is you look at the idea of ruggedization. Excuse me. So these are things that people are thinking about. And I think this makes this a useful slide because it takes you from the idea of basic applied research all the way up to commercial end users. So this is kind of a big deal, and this is what makes this slide very important. Next slide, Joe. Okay, so these are timelines and metrics to track development progress in a quantum foundry going years 1 through 3. And you're going to see some roadmaps that span 20 years, but these are well thought out guidelines and metrics to track the development progress. Because if you think about this, if you're working in a quantum foundry and people are writing checks to pay you on a regular basis to make progress, these are the timelines and metrics that they're going to be tracking you on in years 1 through 3. So I'm not going to read this to you, but I want you to understand the importance that this is what people expect if they're going to be writing checks to see you produce something. Next slide, please. So when you get to years 3 through 8, this is what they're going to be looking for. So you know, just remember this, and I'll just say this. In every organization I've worked in, they always want weekly or monthly status reports. And when you do a status report, it better be the truth. The last thing you want to do is go telling lies about how successful you were. So if you look at the previous slide and the other slide, or this slide, the current slide, timelines and metrics to track your development progress. Just remember when you're writing your status reports, you can't cop an attitude and say, well, yeah, we went into week number 20, but we didn't feel the vibe, so we didn't produce much. No, that's a good way to get fired. Okay, so just remember you've got to keep your eyes on the prize and you've got to keep making progress, and keep your personal feelings and your emotions out of it. Next slide, please. Okay, this is a timeline of development for first generation chip scale atomic clock. Now notice the years here. This goes from 2001 all the way up to 2011. In other words, this didn't happen overnight. It took them 10 years to get from the idea of feasibility all the way up to a commercial product. So the idea is here is that these don't have these ideas don't happen overnight. You've really got to be focused and make steady progress, just like the two previous slides described. Next slide, Joe. This is an example of what's called atom interferometry timeline lab studies to commercial applications. So this took them clearly almost 20 years to get from theoretical from 1991 all the way to 2020. So again, this is another great example that this stuff doesn't happen overnight. And we're talking, this is the beauty of my QSecDef group that meets every Tuesday. We have world-class optimists and practitioners that are doing this stuff for a paycheck. So in many ways, we have people that are uncovering and discovering the science at the same time they're trying to commercially apply it. And so I can't think of any other field on planet Earth that's more exciting than that you have people discovering the science and then turning around and applying it to make something that is financially and economically viable. Next slide, Joe. And here's another example, encephalography. And this shows a young man wearing a sensor probe. In the past, they would do this in some sort of sensory machine, and now they've got this down to a wearable device where they can probe and get information. Next slide, Joe. This is actually a lot more common in the world of quantum sensors than I realized before I did the research for this presentation. But there is something called, I think they call it NVC, which is nitro vacancy sensors. So that and I don't claim to be an expert on this. I'm just a person who's done some research on it. But this is called nitrogen vacancy centers and diamonds allow for magnetometry and nuclear magnetic resonance and NMR spectroscopy and imaging with spatial resolution approaching nanoscale. R&D on NV centers have spanned over 2 decades. So this is not pie in the sky stuff. People have been using this to produce verifiable results. So this is, again, pretty exciting. And they've had participation from the National Science Foundation, NIST, the Department of Energy, Department of Defense, and the National Institute of Health. Next slide, Joe. Okay, so this is the part of quantum sensors that discusses quantum optical effects. And I'm not going to go deep into this except to say that they're using science related to these sensors to to be able to describe things like squeezed light and gravitational waves, and they've actually used this to prove things that people didn't think would be provable in this lifetime, their lifetime, and it can be studied on with LIGO. And next slide, Joe. LIGO is the Laser Interferometer Gravitational Wave Observatory, and this gives you the time scale from when they first theorized about it all the way to where they started using the science. And we've actually had in our QSecDev meeting back at the end of June, we had a young man from the European Space Agency that talked about low orbit sensors, where they're using this technology to harvest some amazing science related to this, and they're using this exact technology. Next slide, please. Okay, so this is some more quantum sensors information, and this comes from my colleague Alain Chancey and his colleagues, and this is just amazing stuff because he basically went out and wrote a book on this, quantum chemistry. Next slide, please. Okay, so he asked me personally, because he liked this presentation, to insert some of his own slides. I'd like people to pay attention here because this is the ultimate in applied quantum sensor stuff. So basically, he's using AI-driven quantum molecular sensing for cybersecurity. Next slide, please. And by the way, my colleague Joe was in on this. Joe, next slide, please. Okay, so the problem was that most people don't understand the internet, but they think the internet is based on satellites. Probably only 5 to 10% of internet traffic is based on satellite transmitted data, but about 90%, over 90% of internet traffic is based on optical cables that are anchored into the seafloors. And so this is a big deal because you've had people like Russia and China tampering with these undersea cables. And this is not conspiracy theory, this is actually fact. China has messed with the cables going into Taiwan. Russia has messed with the cables going into the UK and into the Baltic nations. And so this is not a pretty situation. And so my colleague, Alain Chancey, has come up with an idea of using quantum chemical sensing to be able to determine if cables have been tampered with. Next slide, please. So they're using ultra cold gases as good quantum sensors, and you'll see in the slides that they came up with the this is part of their theorem where they set up the equation. They're physicists and chemists and quantum scientists, so they come up with the equation to be able to define what they expect and also what they find. And for the uninitiated, the notation up in the upper right hand corner there with the straight line and the 1 and the greater than sign, and then the straight line and the 0 and the greater than sign, that is quantum notation for a qubit. And what it's called for quantum people that do this work every day, it's called a kit notation. Next slide, please. Okay, so they're using carbon monoxide as a quantum chemical sensor, and being a guy that understands human physiology, I immediately typed in the chat window, "Oh, quantum, no, carbon monoxide is not a good thing. It combines with hemoglobin and makes carboxyhemoglobin." All that's true, but they were able to contain this in an area that wasn't going to interact with human hemoglobin. So this is the scientific background for this, and they're looking for differences that show that there was some tampering with these optical cables. Next slide, please. And so not only did they come up with this theory, but they were able to simulate it in software. And so, you know, this is excellent science. As far as I know, nobody in the world has been doing this. So these guys are clearly pioneers and leaders in this area. Next slide, please. And this basically shows the how they're coming to the conclusion on their scientific principles here. Next slide. Okay, so how do you establish and operate a quantum foundry? These are the key concepts. Build a strong quantum focused team. Come up with great ideas. Appoint a strong results focus, appoint strong results focused leaders with strong leadership skills, quantum skills, and people skills who can build strong learning teams based on the Peter Senge learning team principles. Build a project plan and a budget, get sponsors and funding, kick off the project, and execute on your team's shared vision. Next slide. Okay, this is real important, and a lot of people totally miss this. This was in my first master's degree that I covered in 2003 to 2004. This is called disciplines of a learning organization. And I'll just go over these quickly. Systems thinking, which is usually the last one they cover. Mental models, shared vision. You want everybody marching on the same sheet, same page, same sheet of music. Personal mastery, which is you bring a whole person to the team. You know, you don't bring your drama to the team, you bring a whole person. And then team learning. And if you put together any team, whether you're Quantum Foundry colleagues or whether you're building homes, it doesn't matter. If you operate a learning team organization using these disciplines, your turnover will be low because everybody will be excited to come to work every day and contribute. And so that's the reason I put my gold star with the red dollar sign here, is this will save you tons of money if you build a Quantum Foundry team and you apply these disciplines. Next slide, Joe. Okay, this is what a Quantum Foundry project timeline looks like over a space of 24 months. There's an initiation phase, planning, R&D, infrastructure setup, core development, verification and testing, implementation and deployment, and then auditing and final review. And across these phases, if you look over to the right, you'll see what the key deliverables are. So a lot of thought went into this. And if you are building your own Quantum Foundry, this would be a very good guideline to put this together. Next slide, Joe. This is what the Gantt chart timeline looks like. And the reason that says TBA is because we purposely did not name a resource. This is a framework for putting all this together. And it gives approximate dates. But the theme here is that you don't just go up to somebody and say, well, we want to build a quantum foundry. You better have your act together and know all the phases and the way the timeline's going to look, or nobody's going to believe you. So this was a well thought out a way to do this. Next slide, Joe. Okay, so these are the examples. We talked about quantum building a quantum sensor foundry as our example. They've actually got one of these. They've got a quantum sensory foundry called Qnami over in Switzerland. Next slide, please. And this is something off their website. They have a nice little circle here where they've got on-chip sensors, the NV diamond, and again that is the nitrogen V diamond that we talked about earlier. They're using that as a sensor component, implementation mask, lithography, and for the uninitiated, lithography is where you use light or X-rays, something in the electromagnetic spectrum, to basically take a circuit that you built and basically etch it into silicon. So this means like lithography. You're transferring something from a light source or an X-ray source into silicon, and then reactive ion etching. So I'm not going to read all the subtopics. I just want y'all to know that this is in Switzerland and it's real. Next slide, Joe. Okay, these are some quick slides I want to go through. In the back of your minds, you're probably saying, well, how big is this market internationally? Well, I can tell you it's in 2024, it's about $375 million, projected to go all the way to $915 million in the next four or 5 years. So it's kind of a big deal. And I invite you to go down into my references and look up QED-C and look at the report that came out, I believe, in March of 2025. This is a real deal. Next slide, Joe. This is quantum computing use cases. I love this slide because it could be a great idea generator. Although I know that we're in the quantum metrology and sensing world, but this is still quantum, right? Next slide, please. Okay, so this tells the quantum industry as of about 6 months ago. The composition is 6,502 quantum engaged organizations. The market is about almost 1.5 billion. The workforce is almost 15,000 pure play quantum workers advancing quantum, and about 7,400 quantum related positions are open. And I hate to say this, it's very complicated to get, it's very complicated and difficult to get in. So the more you participate in quantum meetups like this, Quantum Chicago, Quantum DC, Quantum Alexandria over in Egypt, and also QSecDev that meets every Tuesday, the better off you'll be to get one of these positions. Next slide, Joe. This is the quantum industry workforce as of 6 months ago, and it shows on a world map there where quantum related positions are opening by position type and related openings by organization type. So again, another valuable slide. Next slide, Joe. This is the quantum workforce by role. And in some ways, I hate donut charts that don't make it easy for you to read this, but you have to go down to that black stripe that's on the donut there. That's from about the nearly the 3 o'clock position all to about the, or 4 o'clock position all to the 7 o'clock position. Those are engineering roles, and then there's information technology that are red, and then research. And I'll just tell you straight up, don't plan on getting a research job in quantum unless you have the magical gateway credential of PhD in quantum. And this is something that Joe and I see every week. There are so many people that got the message back in the early 2020s or even before that. They went out and did their due diligence, they did their hard work, and they got their PhDs in quantum computing. So if you want to get into research, you better have a PhD. I'm sorry, but that's the brutal facts. There's also quantum business development. And those guys, many of those people have PhDs, surprisingly. And there's operations, education, sales, program and project management, consulting, arts and design, entrepreneurship, product management, quantum, community and social services, and then other. And so it's not the best donut chart in the world, but to me, this is very useful information if you're planning on a career in this field. Next slide, please. Okay, this is one of the other most valuable slides in this deck. Many of you don't have the background to understand what the I-4004 was, but this was the world's first commercial central processing unit, microprocessing unit. And this guy was challenged by the Japanese Busicom people, build us an entire computer on a chip. And because he had extreme experience in mainframes and mini computers, and he knew about silicon and designing circuits, he stepped up to the challenge. So he basically designed and built a 2700 transistor processor, and that's the block diagram down at the bottom there. Physically, that's what it looked like. This is the block diagram. This is a photo shot of the microprocessor, and this is what the block pin layout was of this microprocessor. But here's what he said in his lecture, and I'm not sure if this guy looks a whole lot like my mentor that I had from 85 to 2018. Amazing man, Ted Hoff. He said this: you could be smart and talented and invent and produce great things, but if you aren't able to demonstrate, if you can't demonstrate the business value and market it and monetize it, you're doomed to fail. And I believe so strongly in this statement that if I had a Quantum Foundry office, this would be like right up on the wall and in a large poster, because you can have a lot of gee whiz stuff, but if you can't make money on it, you shouldn't be doing it. Okay, so this is the reason this will save you a lot of money. I love this slide. Next slide, Joe. Okay, so this is the conclusion. Rapid advances in quantum physics and quantum science have led to the creation of quantum computers and quantum sensors. Using tools like quantum sensors and quantum computers, we're now able to compute things and measure phenomenon in ways that help us discover more science and in shorter periods of time than ever imagined. One essential key to enable the acceleration of the development of quantum technologies will be building a quantum foundry. And as more organizations discover the efficiencies and successes that result from quantum foundries, they will become a preferred method of manufacturing quantum technologies. And this is what's going to advance the art of quantum applications and applied quantum science. Next slide, Joe. This is one of my favorite sayings. This is from the guy that invented the term cyberspace. His name is William Gibson. He says the future is already here. It's not. It's just not evenly distributed. So it's here. Okay. Next slide, please. And then I'll open it for questions because I know that Ron has a hard stop, and I want to be courteous to everybody. Have people got any questions based on the presentation?
So Bill, this Quantum Foundry is it something that you're looking to make happen, or you have made it happen, like as a consortium or as an entity unto its own?
Ron, it's a great question. We haven't made it happen yet, but we feel like we built a credible framework and a compelling case to go do this. And since DARPA's got money to spend, Joe and I are pretty confident that somebody's going to write a check and tell us to go forth and conquer. So I would not say this is pie in the sky stuff. We have a method to go forward, but we have not done it yet.
Seems very exciting. And you also mentioned something about doing these hackathons with prize money. Is this coming out of your pockets, or is it where's it coming from? Just curious. You don't have to answer it if you don't want to.
No, it's okay. I'm probably the most transparent guy you'll ever meet. The quick answer is Joe and I put our heads together, and neither of us can fund it with our own organization, Slater Technologies or the Redix Group. We don't have the resources to fund this out of pocket, but we've done the planning, and we understand that it's going to take about $11,000. And so both Joe and I are men of faith. And so between spending a lot of time in prayer and also using GoFundMe, we hope to come up with a lot of contributors that want to see the participants that are going to sign up advance the cause of quantum, and that it'll all work out.
That sounds very exciting, and I hope to stay abreast of your efforts there. Actually, I'm hoping after going through this with you, I would maybe like to sync up with both you and Joe maybe in August sometime.
Ron, I think that would be wonderful.
Yeah.
And for everybody on the call, if you go to the slide, I'm a very anti-21st century man. If you go look at the stuff about me, I've got my phone number and my personal email address. I'm the guy that you can reach practically 24 hours a day. So by all means, everybody that wants to get involved with me and Joe, please do, because we welcome all comers.
Bill, can I add something real quick?
Absolutely, Joe.
One of the things we've been looking at, everybody, with this idea of the foundry, the quantum central foundry, is a way to stair step our way into ultimate larger quantum. But we felt that the biggest issue, for example, for SOCOM, special operations, tier one, tier two, tier three, is instantaneous information. So we went with the edge or origin, and I call it, it's where the action is, it's where everything starts. So we decided to go with the quantum sensor foundry because we can impact the edge and that type of scenario. And right now I'm at Fort Meade and we're working with, of course, the high school when I present K through 12 and quantum and AI integration as a whole. This is very key to what the Foundry is all about. It's more of an integrated system approach, both from domestic and global scale. And with that, I'll stop. But this has been a great opportunity. And there's a second part of this presentation that is more focused on the algorithm layers and things like that. That's the side of the Foundry that, if you wish, I could give, if that's okay, Bill. Okay, that's it for
Sure.
me.
It's perfect.
Does anybody else have questions? I don't want to monopolize the Q&A session. Feel free to put a question in the chat or just jump on the microphone.
Yeah, I have
Go
a
ahead.
quick question. Yeah. First of all, thank you for the presentation. Very interesting to see kind of where the developments are headed right now in quantum. I have a quick comment and then a question. So my comment is, I saw a few weeks ago a presentation about a space technology accelerator that is being that's sort of been put together and I believe in the state of New York. I think it's called like Techstars or something like that. And I saw a lot of their approach was very similar to what you were talking about, William, with this, kind of, not just, like building a whole ecosystem where where you can quickly develop and iterate things within the ecosystem, as opposed to just a one-off pipeline or something like that. So very interesting. I think there's definitely a lot of I guess a lot to learn from the different approaches of other technology accelerators. I've seen similar things with nanotechnology. There's a lot of initiatives like this, where there's sort of this public-private partnerships and things like that, to kind of create these things. So very interesting to see that applied to quantum. And my question is, I guess, I come from a like a software development background, and I've been looking at how I can contribute to quantum. I don't see myself getting a PhD anytime soon, or well, who knows? I won't rule it out, but I'm just wondering kind of, obviously not everyone in the field as it develops to be the, multi-billion-dollar industry is going to be at that level of research. So I'm wondering kind of like where are the pathways for someone with my background to kind of ramp up into that, or just dip my toes, even just to see kind of how I can contribute.
Sure. Here's some observations for me. And I'm old school. I started programming in September '73, and I never did anything in technology um, before I graduated that I thought would lead to a career. I did it because it was fun. I was supposed to be an Air Force pilot and go drop napalm on people. This is from the '70s. I was a total brainwashed warmonger. So over the years, I programmed in 43 um, different languages. I love to code. I love to turn ideas into applications. My advice is, and there's a lot of resources out there. I would we can have some offline Zoom conferences about this, but my advice is to learn the differences between conventional computing and quantum computing, and also learn how quantum circuits work and why you would want to work with things like qubits and why qubits give you an advantage over conventional computing. You do not have to be, um, in my opinion, you don't have to have a PhD. It does have to, it does work to your advantage to understand, be able to read intro to quantum papers that have some math and stuff. But if you get involved with people that can mentor you and head you down that path to where you're making a successful transition between being a conventional programmer and a person that knows how to program quantum computers, that would be an optimal situation. I want to tell everybody on the call, uh, I have a significant quantum library, and that's reflected in that list of references there. There's an O'Reilly book called Programming Quantum Computers. Fantastic book. I think the guy's name is Johnson. He's one of 4 authors in that book. But are some spectacular resources out there. If you just do old-fashioned hardcore application of yourself to learn this stuff, you can learn this stuff and then fly with the big boys, you know. So don't, just throw caution to the wind and decide, I'm going to do this. I'm going to put in 2 hours a day and learn this stuff. And I'll also tell you, go get involved with every quantum meetup that makes sense, like QSecDef, Washington DC Quantum Group, the Chicago Quantum Group, and the people over in Europe and Alexandria, Egypt. Get involved with those people, and maybe even go to quantum hackathons. Our quantum hackathon is going to be 30 days, and we're going to have mentors. And so if you don't know something and you have a conceptual idea, you'll be able to access mentors to help you get to completion. So the field is just sucking everybody up that loves this stuff and wants this stuff. Don't be discouraged. Just jump in and get your feet wet.
Can I add something real quick, Bill?
Absolutely, Joe.
You know, when you're looking at a concise way to gather the most up-to-date information, I've been on LinkedIn for 21 years and I have a presence there. But to answer your question, I would send a link and invite to me. We publish and integrate a lot of information that will fast track your knowledge requirement. Okay.
Yep.
Now it's Joe Reddix, and that's on LinkedIn, and you can Google. But the beauty is, we can fast track a lot of what you're asking for as far as enhancing your knowledge level. Isn't that correct, Bill?
That's correct. And the phenomenal part about QSecDef, maybe we just been lucky, but my observation is, I've been in the field 48 years. Joe's been in the field 58 years. We wouldn't keep coming out to QSecDef every Tuesday if there were people that we perceived to be jerks. So stay away from the jerks. There are so many good people that we run into that have big hearts, who will share what they know with you. Some of them won't share everything, like me and Joe, but they will share a lot. So seek out the good people in quantum. And I've been in the field 48 years. It's never been a more exciting time to me than right now, because this is the future. and it feels good to be here.
Yeah, thank you. Thank you both for that advice. And yeah, Joe, I will definitely look you up on LinkedIn to see those resources you were talking about. And William, yeah, thank you for all that advice. And I already took a quick peek at the references on that PDF of the slides, and I can see it's very extensive. So I will definitely be perusing those and making sure I I can see, like, prioritize kind of which ones kind of hit what I'm looking for. So yeah, thank you so much.
Sure, you're welcome.
Hi, I just wanted to second your advocacy for that book you mentioned, Programming Quantum Computers. It's actually really good. It's very good at understanding, I guess, the bit size leveled operations that you're going to do on sort of quantum states. I did have a question as well. You mentioned at the beginning of the talk that you do some projects involving quantum security. I was wondering what sort of projects that you do for your businesses.
That is like new territory for me. I would from my experience, I would say it sounds like Ron has a bit more experience in this, because from what I understand, Ron eats, lives, and breathes his stuff from the time he gets up every day till the time he goes to bed at night. The quantum security stuff that I'm working in actively right now is related to PQC, and I have a feeling that probably most people on the call here were not involved in the Y2K remediation, but I was, and it was horrifying because everybody waited till about August or September of '99 to get their act together, and they knew that they better have everything together by midnight on December 31st of 1999. The problem with PQC, which is post-quantum cryptography, is that nobody knows when Q day is coming, but they know that it's coming. And so I've heard some estimates going all the way from 2 years from now to 5 years from now, but it's definitely not 2035. So the quantum security stuff I'm involved in right now is trying to help people put together projects, and fund projects that are going to address their PQC needs, which everything that your computer is interacting with on the net, from digital certificates to encryption algorithms, that's all going to have to change. And the way that's going to change is to come in and do a fearless inventory using tools like SBOM, which is the software bill of materials, and the cryptography bill of materials, which is also called a CBOM. And a good project manager that understands this is going to direct the activities to get all those things converted over, so that none of the data that traverses the wire is going to be crackable by some person that's using Shor's algorithm on a strong quantum computer. That's really what it gets down to. The guy that came up with Shor's algorithm was MIT professor by the name of Peter Shor in 1994. And most people don't know this, but a couple of years ago, he received a $3 million award, which he split with his partner to reward him for coming up with Shor's algorithm. But you can go look up, Shor's algorithm is spelled SHOR, S, or excuse me, apostrophe S, and go look that up on Wikipedia, and you could read about it. But that's the thing that keeps people up at night, because they realize people in China especially is capturing data right now, expecting to decrypt it in the future when they get a powerful enough quantum computer. So that's the type of quantum security stuff I'm working on right now. And I'll also tell you, you can benefit a great deal by going back and researching quantum history and looking at people like there's a American-born Indian woman by the name of Urmila Mahadev, who came up with the algorithm. God bless her. She spent 8 years beating her head against the wall to come up with the algorithm to verify that a quantum computer had solved your problem. And right now she's working at Caltech. But I would invite you to go back and look at the history of quantum technology and quantum physics, going all the way back from 1927 at the Solvay conference and going forward, because there's a lot of great minds, great spirits that have worked on this stuff, and that this is a field. I feel strongly that people like this matter because they incrementally develop the science that we're working with now to build the future. So these are important people, and I would learn as much about the pioneers as I could. But that another book y'all should read is Quantum Sense and Nonsense by a person named Gene. Gosh, I want to say Gene Brickman or something like this, Bricman, who wrote this fantastic book that gives the history of the people that put all this stuff together. But and Ron, I don't know if you guys are going to do this, but I'm really pushing for a big celebration in October of 2027, because I want to celebrate these people that had this landmark quantum conference, and I think it was in Brussels, called the Solvay conference. And there's like 37 people in this picture, and 35 of them got Nobel Prize awards in physics.
Sounds like something worth putting on the calendar a couple years out. I'll just follow up on the PQC stuff. So everybody knows about Shor's algorithm. It's not the only algorithm. There's another one that's that
Grover's algorithm?
it's not Grover's. It's basically since all gate-based quantum circuits rely on these unitary operations, they're all reversible. So you write a quantum program that does the multiplication in reverse. And I've done this on DWave and was able to factor like some number in between 30 and 50 or something like that. And that has just as good, in my opinion, has just as good a chance of breaking cryptography as Shor's machine. Shor's machine, when you look at it and you look at his algorithm is brilliant. There's no doubt about that. But it's going to take not only a ton of qubits, but a machine with a ton of coherence and a ton of width. Part of his algorithm involves an inverse Fourier transform, and that is incredibly qubit heavy, even at a small scale. So, and it scales linearly, but that's why you'll hear them talking about you need millions and millions of logical qubits to do Shor's. But there's stuff that's going on today, and Bill, I mentioned to you there is a company called Quantum Foundry, and I've met with them. Actually, they had a thing here in Chicago. Their whole thing is they call their byline is we do quantum safe networking. Sorry guys, there's no such thing. It's it's quantum resilient maybe, but to call something quantum safe, you're just setting yourself up for failure. But they're working with Nokia. And this is something you might want to talk about in your foundry and you're talking about sensors and hardware, is quantum key distribution with dedicated hardware. Nokia is doing this. You can go buy this these endpoint blades from Nokia that will do quantum key distribution on it. It has to be a single fiber segment. It can't have any interruptions in it. So your errors, depending on who you talk to, it's between 12 and 20 kilometers is the cable length you can run. But for trading companies like on the across the river from Wall Street on the New Jersey side, these people are using this technology because they only got to need a cable to go under the river and come up on the other side. So it's a very short haul. But the major thing people need to understand now is start your planning. It doesn't matter whether quantum's going to mess up your day or some bright 11-year-old hacks something and breaks the algorithm in a different way. You have to be able to be very agile, swap out your encryption mechanisms, on a dime. That's really the thing that gets lost in all of this noise, because they refer to it as a cryptographically relevant quantum computer. It's an acronym that, because NIST likes acronyms. Don't wait for it. Plan now.
Fine.
Sure.
Don't wait for it. So
Okay.
Guys,
Hey,
there's
Bill.
also there's a an RFC. That stands for request for comments, but that's the standards that the internet's built on. To add to what Ron just said, if you go look up two RFCs, one of them is RFC 7696, which is about crypto agility. And what Ron just said was related to the term crypto agility. You want to be cryptographically agile, so that changing from one crypto algorithm to another won't be like ripping out the foundation of your house. You want to have some flexibility there. The other RFC you ought to go look up is RFC 9340, that has to do with the architectural principles of building the quantum internet. And that gets into things like entanglement, Bell's pairs, things like that. So again, I'll repeat those: RFC 9340, which is an informational RFC, by the way, and then RFC 7696. And if people want to contact me after this and discuss what I know about PQC, I'll be happy to share resources. I've been to probably 30 or 40 hours of conferences about PQC alone, and I'll be happy to share what I've got. And if you want some mentoring or some assistance on learning this, it's a viable career path.
Sorry, no, Bill.
Yeah, Joe, I'm sorry. Go ahead.
Oh, no, Ron, you getting ready to say something?
I was just going to say we're at 8:05. I've got about 5 more minutes.
Okay.
Let me just say that our group here, Quantum Computing Chicago, Illinois, and beyond, if you go on our meetup page and look at past events, you'll see some of these topics were handled. A number of them do have links to videos, so you can go back and watch. I'd also would point out that one of those past events was a presentation I did with some of my colleagues on quantum sensors, specifically nitrogen vacancy and diamond centers. So I know way too much about that. So go ahead, Joe.
Okay. Okay. What I was going to say is that, you can go out to LinkedIn, but the Redix group has a slot on what is called the DARPA ERIS Marketplace. That's Expedited Research Implementation Series. It's something that goes on until August 31st. But I'm in that marketplace with my company, and one of the things you have talked about was security as related to quantum. Well, we're doing a Ryberg, software-defined antenna kind of project, which is right in line with what you're talking about. That, security level layer is definitely going to be chip level, but that's kind of like, answer your question about what we're doing with quantum and cybersecurity. our key is that edge cybersecurity foundational capability has got to be there, and that's what we are also working on. But I'm already saying that the team is working with DARPA through this Ares type of marketplace, and they use OTA, other transaction authority. You present a 7-minute video, you do the quad chart. If they like it, my first one, for example, was 92.5 out of 100. But it's a good segue to go in with advanced research deep into DARPA. And with that, I'll stop. Okay, Bill?
Sure. Ron, everybody, thank you so much. I enjoyed being here, and I'll come back anytime you invite me.